Hi everyone, in this video I'll be going over how to create a turnout block in Civil 3D. For this you're going to need some kind of schematic or plan of a turnout. For this example I'll be using a CN number 8 turnout. Um, so there are two key absolute minimum measurements that you need for a turnout, which would be the point of switch to your point of intersection, and you're gonna need the angle on your turnout. So how we'll first start is get the PS to PI distance, which is 9.112 meters in this case. So um, just start with a simple line, just anywhere, go straight at 9.11112, and we'll zoom in here, and then another line. I'm just gonna draw a random distance, doesn't really matter. Um, and we want to rotate this second line by the angle of the turnout, uh, which we can find here at which is number 18. Um, just 7 degree, 9 minutes, 10 seconds. So I'm going to rotate this line by the frog angle, which is 7 degrees, 9 minutes, 10 seconds, like that. And if you want the bare minimum for a turnout block, uh, this is basically all you need. Um, because it will give you the PS to PI, and your PS location will be correct, and the angle of your divergent track will also be correct for a number 8 turnout. Um, to make this a little bit more informative and detailed, we can include the frog. Um, and to include the frog, there are a couple of things that we need. First, we need the actual lead, and we can get that by this dimension, 20.693. So what I'll do is I'm gonna draw a line, vertical line, and wrong PDF, it's 20.693. 20.693. Um, and then to actually get the outline of the frog, we're gonna divide it by the gauge, half gauge. In this case, it's 0.71755, something like that. And you'll notice there's the point that they intersect. That's called a theoretical point of frog, and this is the point of half inch point. And I'll explain that in a little bit more after I finish drawing this up. So the other thing we need is the extent of the frog. And in this case, I believe this is the SGM frog. So we're gonna go 0.889 from the the half inch point, not the theoretical point. So 0.889, which is this line. That is the toe of frog. And then now we're going to get the heel of frog, which is 1.829. 1.829. There we go. Now we can just start trimming some of these lines up. That. And now we got a frog. Um, I like to keep the half inch point in there just in case it's useful. most of the time we don't really care about it, but basically the theoretical point um, is just it's just a theory. It's just in theory. The actual half-inch point is what exists on the site. Just because if they were to leave this theoretical point, it would chip off. It would be such a sharp line that the wheel would just break it up and potentially damage the actual frog itself. So they'll grind the frog point down to where it's about half-inch thick. And now the last step, I guess, would be to just get the correct length of turnout. Okay, to get the actual length of the turnout, we're gonna have to do a little bit of math because the plan gives us the overall length of turnout, and most of the time we're only concerned with the point of switch to the last long tie of the turnout. So to start that off, we're gonna have to do um, start with 30.886, and then we're gonna have to do 5 spaces at 0.521, which would be, I'm gonna just use my phone here, 0.521 times 5 is 2.605. And then we're gonna have to go another 0.546 to get to the center of this tie. So another 0.546. And then now we're at the center of this head block tie. We're gonna have to go another 89 millimeters to get to the point of switch. So I'm gonna add 0.089, and now we have the overall turnout length, not overall, sorry, the point of switch to long tie length of 27.824. So I'm gonna go back here, 27.824, offset this line, and that's the end of the long tie, or the end of the turnout ties. So I'm gonna trim that off. I will trim that, and this is the basic overall shape of number 8 turnout. And I will just create a circle here just to resemble a switch stand, I guess, or the side of the switch stand. And can do that. And then I'm gonna do the final step of making this into a block. So we can name it CN number 8 turnout. And your insertion point, you can either pick the PI or the point of switch. It's up to your preference. I'll pick the point of switch and hit OK. And that is the basic turnout. And really quickly, I'm going to show what the importance of of a block like this is. If you look at one of my videos for the proposed siding track, you'll notice I use a turnout block. Um, so normally we'll have an alignment. I'm just going to create a quick alignment. It's just straight. You'll have an alignment like this. And then what you'll want to do is you're going to want to create like a siding track or something, for example. So if I were to offset this by 14 feet, which is 4.267, now this is my adjacent track. I'm going to have my turnout here. I'm going to rotate this so that it's aligned. You can alternatively use the align command. And then I can draw a line like this. So if I were to create my new siding alignment, let's call this siding. You can start from your point of switch, go to the PI. You can go to the intersection of these two lines. Can do something like this. And let's just give it a curve. And let's do 200. And there you go. So the purpose of the turnout block is so that your dimensions on this um, alignment is correct. So you got the correct PS to PI distance, and you got the correct angle, so that when they go to construct this, everything fits into place. Um, in a future video, I'm going to show you how to use a turnout block like this to design a crossover. Okay, thanks for watching. Bye.